The problem is from GATE 2015 Mathematics paper, question number 13. The problem given is, let M be a 3x3 singular matrix and suppose that 2 and 3 are eigenvalues of M. Then the number of linearly independent eigenvectors of the matrix MQ plus 2M plus I3 is equal to. So it is given that M is the 3x3 matrix with, in fact, it is singular matrix. So one should know some properties of singular matrix. Singular matrix means it is not invertible. And for such kind of matrices, we can say 0 is one of its eigenvalue. Since to solve this problem, we use the eigenvalues topic. So I'm just saying what the one of the property of singular matrix which we use to solve this problem. And it is given two more conditions, that 2 and 3 are its eigenvalues. So in total we have 0 is one of its eigenvalue as it is singular matrix, and 2 and 3 are its another two eigenvalues as it is given 3 cross 3 matrix. So it has three eigenvalues. So in total we have 0, 2 and 3 are its eigenvalues. So then it is asked the number of linearly independent eigenvectors of this matrix MQ plus 2M plus I3, where I3 is nothing but the three identity matrix of our 3 class 3. So the NPTEL reference to solve this problem is Module 7, Lecture number 26, with the title Eigenvalues and Eigenvectors of Linear Operators. So from the topic Linear Algebra. This lecture is by Dr. K.C. Sivakumar. He is from Department of Mathematics, IIT Madras. Even you can watch this reference video, use this YouTube link. So now coming to the solution. It is given that M is of 3 cross 3 order and it is singular matrix. That implies 0 is one of its eigenvalue. And it is given one more condition, that 2 and 3 are its eigenvalues. So in total we have 0, 2 and 3 are the eigenvalues of the matrix M. So we can see that all these eigenvalues are distinct. So we can say, so the eigenvectors, since it has three distinct eigenvalues, so the matrix M. So M has three distinct eigenvectors. Eigenvectors corresponding to each eigenvalue 0, 2 and 3. Distinct eigenvectors. That is, it has three. Okay, let me say those eigenvectors are, let those be I1, I2 and I3. These three are the eigenvectors corresponding to these eigenvalues of the matrix M. But then what it is asked to calculate is to see the number of linearly independent eigenvectors of the matrix MQ plus 2M plus I3. So before looking at the independent eigenvectors, firstly we see what are the eigenvalues of this matrix. So it is given that MQ plus 2M plus I, in fact I3. So we have the eigenvalues of M are 0, 2 and 3. So from this we can see eigenvalues of 2M are nothing but 0, 4 and 6. These are nothing but the multiple of the eigenvalues of the matrix M with the scalar 2. Since this is why, because since we have mi1 equal to 0 i1. So from this we can see 2m i1 is also nothing but 2 times 0 times i1. And similarly 4m i2 is nothing but m4 i2. So whenever we have the eigenvalues as 0, 2 and 3, we have, sorry, here we are looking for the eigenvalues of 2m. So we have 2m i2. This is nothing but 2 times 2i2. That is nothing but 4i2. Hence 4 is the eigenvalue corresponding to the matrix 2m. As we have 2m i2 is nothing but 4 times i2. So 4 is the eigenvalue of the matrix 2m. Similarly for the rest of the eigenvalue 3. So we can say the eigenvalues of the matrix 2m are nothing but 0, 4 and 6. Similarly, the eigenvalues of m cube are 0 cube, 2 cube and 3 cube. And these are nothing but 0, 8 and 27. So, and finally, the eigenvalues of I3 are nothing but 1, 1, 1. So we have the eigenvalues of each matrix separately in this expression. So, and we can see all eigenvalues corresponding to each matrix in this expression are distinct. So we can say, so the eigenvalues, eigenvalues of the matrix m cube plus 2m plus I3 are nothing but 0 cube plus 0 plus 1. This is one eigenvalue. And then 2 cube plus 2 into 2 plus 1. And then 3 cube plus 2 into 3 plus 1. That is nothing but 1 comma, this is 13 comma 34. And we can observe that these eigenvalues are distinct. And all the eigenvalues of m cube plus 2m plus I3 are distinct. Hence, when we have n distinct number of eigenvalues, we can say it has n distinct eigenvectors. Hence, m cube plus 2m plus I3 has 3 distinct eigenvectors. And those vectors are nothing but these vectors I1, I2, I3. And one can prove with corresponding to the eigenvalues 1, 13 and 34. Corresponding to these eigenvalues, again these three are the eigenvectors of this matrix m cube plus 2m plus I3. Hence the total number of distinct linearly independent eigenvectors of this matrix are nothing but 3.